One function of the operating system is to handle interrupts. An interrupt is a signal sent to the processor indicating that a device or process requires attention. An example is a hardware interrupt, such as a key being pressed on the keyboard, a mouse click, or a printer signaling that it has run out of paper. A software interrupt may be caused by an error, such as dividing by zero, or a program requesting an input or output operation. Another example was a timing interrupt used by the operating system to switch between processes during multitasking. Let's look at how the operating system and the processor work together to handle interrupts. During the fetch decode execute cycle, the processor checks for any pending interrupts at the start or end of the cycle. If an interrupt is detected, the processor compares its priority with that of the current process. If the interrupt has a lower or equal priority, the current process continues running. If the interrupt has a higher priority than the current process, the processor will temporarily pause that current process. The contents of the CPU registers are copied onto a stack, so the process can be resumed later. Stacks are a LIFO or last in, first out data structure, meaning that the most recent item pushed or added is the first to be popped or removed. A flag, which is a true or false Boolean value, is used to show whether interrupts are enabled or disabled. When an interrupt is handled, a flag is set to indicate that the processor is servicing it, preventing lower priority interrupts from interrupting the process. Next, the program counter is updated to point to the relevant interrupt service routine, which is a special program that handles the cause of the interrupt. A common misunderstanding is that there is just one interrupt service routine, but there's actually a separate ISR for each type of interrupt. Once the ISR finishes executing, the processor pops the previous registered values from the stack. This ensures that processes are resumed in the correct order. Once the ISR is complete, the flag is reset, allowing new interrupts to be processed. If a higher priority interrupt occurs while another interrupt is being serviced, the current interrupt service routine is also pushed onto the stack, and the new, higher priority interrupt is handled first. After it completes, control resumes to the previous interrupt service routine and then back to the original program.